Hey all, welcome to Homeschool and welcome back to class 11 chemistry series. And we are with chapter number 3, that is classification of elements and their periodic properties. See, in my previous video, I covered everything about genesis in the classification of elements. That means all about history of periodic table. See, this entire chapter is all about knowing periodic table and understanding periodic table in a detailed way. See, in the genesis of classification, we covered about Dobriner's law of triads, Newland's law of octaves, Lothar-Meyer's curve, and Mendeleev's periodic table. And today we will learn about the present periodic table that everyone are using, that is modern periodic table. Okay, so or I can call it as modern periodic law, or it has another name called long form periodic table. Okay, so let me write it, modern periodic table. Okay, let's understand everything about this modern periodic table. See students, one more very information that I would like to share with you. See, we are not covering the concept in a rough way. We are covering the concept in a very detailed way. We are covering it in a best possible way. I can definitely tell you that these concept videos are not less than any coaching institute. Okay, so don't take it in a lighter way. Note down all the points in your book. Okay, learning with pen and book is very important, and revise them carefully. Definitely, if you can follow these videos, you will get wonderful results in your competitive examinations as well as in your board examination. Okay, so I am again telling you, they are not less than any coaching institute videos. All concepts, all NCERT concepts I am covering in a best possible way. I am not leaving any concept. Okay, so please pay attention, and you can share these videos with your friends also. You can share this with the children who are deprived from education, and I'm mainly doing these videos for children, those who cannot afford for coaching institutes, right? So take the best use of videos and come up with very good results. Okay, so let me quickly start this modern periodic table here. See, the person called Henry Moseley gave modern, I'm sorry if I am wrong with the spelling. Okay, so this person gave modern periodic table. See, before this there were many periodic tables, and most of the periodic table considered, not most of them, all of the periodic tables before this arranged elements with the help of atomic mass. They considered the property called atomic mass, and based on that they have arranged the elements. But this person, by lots of experiment, he understood that it is atomic number that we have to consider, but not atomic mass. So how did he come to know that it is atomic number is a very important property of elements but not atomic mass? It is by X-ray studies. Okay, so what he has done was, he bombarded high-speed electrons. Okay, he bombarded high-speed electrons onto a metal, onto many metals. Okay, onto many metals. And you know, when he bombarded high-speed electrons onto a metals, there he observed, you know, emission of X-rays. Emission of X-rays. And he studied the frequencies of these X-rays. So what did he do? He actually studied frequencies. So frequencies of X-rays, right? And you know what? He observed that these frequencies were directly proportional to atomic number of metal. Okay, atomic number of metal, right? So actually square root of frequency was directly proportional to atomic number. right? So when he plotted a graph of square root of frequency versus atomic number, he actually got a straight line. So with this, he confirmed that, atomic number is the important property of element, but not atomic mass. There was no connection between the frequency of X-rays and atomic mass, but definitely there is a connection with frequency of X-rays and atomic number. So this way he came to know that we have to consider atomic number for the arrangement of elements, but not atomic mass. So he formulated a law called modern periodic law. We say it as modern periodic law. So this modern periodic law says that, this sentence is very, very important, guys. Chemical and physical properties of elements. Chemical and physical properties are of elements are the periodic functions of their atomic number. Okay. So what do you mean by this sentence? Periodic functions of their atomic number. Okay. It means that chemical and physical properties of elements mainly depend on atomic number, but not atomic mass. Okay, so that is the actual meaning of this particular sentence. So now, based on the increasing order of atomic number, he arranged elements into several groups and periods. He arranged elements in 18 groups and 7 periods. See, the concept of period and group we have discussed in Mendeleev's periodic table, right? So group is a vertical column and period is a horizontal rows. So how many horizontal rows were there? 7. How many vertical columns you will find in a periodic table? 18. And now let us understand the periodic table. I will show the periodic table on a board. You have to do the same way in your book. So knowing about the position of some elements in the periodic table is very much essential for class 11 and 12, right? So along with me, you can draw periodic table in your books. Observe, students. So there are 18 groups. So let me draw 18 vertical columns. You see, the shape must come here. So all the 18 groups are not equal actually. Okay, so this is group number 1. Let me write it little above. Group number 1. This is group number 2. This is our group number 3, group number 4, group number 5, group number 6. Okay, and 7th group, 8th group, 9th group, 10th group, 11th group, and 12th group, right? So it's better if you can draw in your books, because knowing about periodic table is really very, very important. So this is a 13th group, 14th group, 15th group, 16th group, 17th group, and 18th group. Actually, my way of drawing a diagram is not that neat, but you can draw much more neatly than me. Okay, fine. Okay, so now 18 groups I have shown. Actually, if you look at the textbooks or any other books, instead of 1, 2, 3, 4, you will also find 1A group, 2A group, 2B group and all, right? So that's an old way of giving names for groups. It's a conventional way of giving numbers. Okay, say Mendeleev has given this type of numbering. So even in our modern periodic table, this way of Roman letter numbering you will find. But IUPAC has changed the numbering in a different way. It made more easy, right? You can use 1, 2, 3, 4, 5, 6 for numbering a group. Fine. After this, let me fill up the elements here. So actually, the hydrogen, the element hydrogen with atomic number 1 is placed here, and second element actually comes here. Second element comes here in the 18th group. Okay, so the first element is hydrogen with atomic number 1, second element is helium with atomic number 2. So this is our first period. So the first period has only 2 elements, guys. Okay, so let me write it here. First period has only 2 elements, that is hydrogen and helium. And coming to the second period, right? So can you able to guess how many elements can be present in a second period? Second period, the third element with atomic number 3, that is lithium comes here, beryllium comes here, boron, carbon, nitrogen, oxygen, fluorine and neon. Okay, so that is our second period. Coming to third period elements, you know, neon's atomic number is 10. 11th element is sodium. Here comes magnesium, right? And here is our aluminium, and below carbon, silicon, phosphorus, sulfur, chlorine and argon. So till atomic number 18 we have finished so far, right? And now in the second period you will observe 8 elements, guys, right? Even in the third period you have observed 8 elements. Remember this number of elements in a particular period, that is important. Fine. And coming to our fourth period, it is quite a bigger period, definitely. And how many elements can come in this fourth period? You see all the 18 groups are occupied, right? So let me fill up the second period. Their atomic number 18 was a end, atomic number 19 is for potassium, and atomic number 20 is for calcium, atomic number 21 is for scandium, titanium, vanadium, chromium, okay, manganese, iron, copper, then nickel, and here comes, sorry, this is a cobalt, and Cu is a copper, and here is a zinc. Okay, and let me fill up boron, aluminium, gallium. Okay, so here comes indium and thallium, right? Carbon, silicon, germanium, tin and lead. And here comes phosphorus, arsenic, antimony and bismuth. Oxygen, sulfur, selenium, tellurium, polonium. Fluorine, chlorine, bromine, iodine, astatine. Neon, argon, krypton, xenon, radon. Okay, see, I have actually completed your 13, 14, 15, 16, 17, 18 groups. Okay, see, actually I am showing the elements that you have to remember for class 11 and 12. So whichever elements I mention, those elements you have to remember their positions. That's very important. So here I will fill, right? So this is our actually fourth. This is our fifth period, right? And this is our sixth period, and this is our seventh period. Right? Okay. So coming to the first group elements, lithium, sodium, potassium, rubidium, cesium and francium. Okay. Here calcium, strontium, barium and radium. Right? Okay. So these are actually some important elements that you have to remember. See, again below scandium you have yttrium, lanthanum, actinium. Okay, and again below titanium you will find zirconium, hafnium and rutherfordium, right? And here this group elements again you need to remember. After zinc you have cadmium, mercury. Okay, so I think these are some elements you have to remember in a periodic table for class 11 and 12. At least these elements you should know. Fine. And you see all, okay, so let me not write all these elements, right? So they are okay. If you can remember, you can remember, okay, but this is compulsory to remember. and I filled all the 7 periods here. And can you all tell me like how many elements you will find in 4th period? See, fourth period you will have 18 elements, and coming to a 5th period also 18 elements you will find, whereas 6th period and 7th period, okay, you don't find 18 elements. See, what actually happens here is lanthanum's atomic number is 57, whereas hafnium's atomic number is 72. Okay, and here similarly in the 7th period actinium's atomic number is 89, rutherfordium's atomic number is actually 104. You see, there is a difference, right? After 57, 58th element must come here, but how many elements are missing? Elements with atomic number 58 to 71 are missing. Let me write it here. Okay, elements with atomic number 58 to 71 are missing. Again in the 7th period, if you see, okay, if you see elements with atomic number 90 to 103 are missing. Okay, so where are these elements? Okay, they are placed separately below the periodic table. Okay, so the elements with atomic number 58 to 71 are placed here. Okay, and elements with atomic number 90 to 103 are placed here. So which is the element that has got the atomic number 58? It is cerium. Okay, and 71 is lutetium. So cesium to lutetium are placed here, right? So actually cesium, where will it come? After lanthanum. Okay, so after the element lanthanum, that is atomic number 57, cerium will come. Okay, cerium to lutetium are placed here. Okay, and now, so here is actually your actinium, that is atomic number 89. After 89, atomic number 90 should come. The element is thorium, right? So thorium to lawrencium. Atomic number 103 is for lawrencium. So these elements will come separately below the periodic table. So 14 elements between this and 14 elements between this and this are separately placed because they have different physical and chemical properties. And in all these elements, the last electron is present in f orbital. So that is why, since they are showing different chemical and physical properties, they are placed separately below the periodic table. But what is their position? What is their position? So where do they come? All of them from 58 to 71, all of them will come in third group, right? All of them must belong to third group and 6th period. They must belong to third group and 6th period, right? And what is the position of elements from 89 to 103? Where should they come? All of them must come in third group. They will also come in third group and 7th period. 7th period. Say location of these elements are very, very important. Okay, fine. So now actually they should come. They are located here only. Since they show different properties, they are placed separately. But location, when somebody asks, you will mention they belong to third group, whereas 58 to 71 belong to 6th period, 89 to 104 belong to 7th period. Okay, so usually these elements are called with the name lanthanoids. Whereas these elements after actinium they are coming, right? So they are called with the name actinoids. So these guys from 58 to 71 are placed after lanthanum, La in the sense lanthanum. So they are called lanthanoids, and after actinium they are placed. So these guys are called as actinoids. Okay, so position of lanthanoids and actinoids is very, very important. Okay, now can you tell me how many elements can be present in 6th period and 7th period? See, 18 plus 14. So how many are these elements from 58 to 71? 14. So 18 plus 14, it is 32 elements. Okay, so 6th period will have 32 elements, 7th period also 18 plus missing elements from this position, that is 14. So here also 32 elements you will have. Okay, so can you decide which is the shortest period and which is the longest period? Definitely I can say longest periods are 6th and 7th. So these are longest periods. Shortest period is our first period, right? It has only 2 elements. So this is something about periodic table that you need to remember. Now let us understand importance of group number. So there is a significance for group number. So looking at the group number, we can decide many things. Okay. So first thing is, all elements which are placed in a same group will have similar outermost electronic configuration. Very, very important. Okay, all elements in a group, shows similar, that means similar outermost electronic configuration. For example, if you want, you can check it out. So let me consider the first group. So which all elements will come in first group? Hydrogen. So we have learned how to write electronic configuration in the previous video, right? So what is the electronic configuration of hydrogen? 1s1. Now electronic configuration of lithium, it is 1s2, 2s1. And for sodium, it is 1s2, 2s2, right? 2p6 and 3s1. Like that, when you write it for potassium, outermost electronic configuration 4s1 you will find. After potassium, what do you have? Rubidium. Rubidium 5s1 will come. Okay, you see 1s1, lithium 2s1, sodium 3s1, potassium 4s1, rubidium 5s1. Like that, for cesium 6s1 will come. For francium 7s1 will come. I'm talking about outermost electronic configuration. And we all very well know that the electrons from outermost orbitals will participate in chemical reactions. Okay, see, in all the first group elements, the outermost orbital, that is the s orbital, is the outermost orbital. How many electrons does it has? 1 electron. So all of them can give that 1 electron during chemical reactions. Okay, so it is that 1 electron which is responsible for the chemical reaction. That means I can say that all these guys which are placed in a same group behave in a similar way. They almost show same type of chemical properties because it is the electron that has to participate in chemical reaction, and all these elements have 1 electron in the outermost orbital, so they will definitely show similar chemical and physical properties. Okay, so this is the importance of group, guys. Okay, and similarly, the elements present in the second group will have the general electronic configuration as ns2. Okay, so these guys they have shown general electronic configuration ns1. Okay, so n can be a period number. If it's a hydrogen, n is 1. If it is a lithium, n is 2. If it is a sodium, n is 3. I'm just writing outermost. This is outermost electronic configuration. Okay, so like this. So all elements which are placed in a same group will definitely have similar outermost electronic configuration. Okay, say here if you come to 13th group elements, they will show outermost electronic configuration as ns2 np1. p orbital will get filled up. I mean, if you check the electronic configuration of boron, you will get 2s2 2p1. Okay, for aluminium you will have 3s2 3p1. For gallium you will have 4s2 4p1, like that. N is actually the principal quantum number present in a element, right? Actually N has a connection with the period number, guys. Okay, so period number will tell you which is the last shell in a particular element. See, what is the electronic configuration of boron? Outermost, 2s2 2p1, right? See, where is boron present? Boron is present in second period. What is the outermost electronic configuration of sodium? Check here. It is 3s1. You see, third shell is the last shell. So, this sodium is placed in third period, right? So, period number. I'm talking about the importance of period number. So, write it. Period number tells about the last shell number. Okay, for example, calcium is there. If I ask you which is the last shell in calcium, I can definitely say calcium comes in fourth period. So calcium's last shell is fourth shell. I mean, the electron is present in the fourth shell, right? So this way you have an importance for group number and period number. Okay, so 14th group elements will have outermost electronic configuration as ns2 np2, and 15th group elements will have ns2 np3. 16th group elements will have ns2 np4, and these guys ns2 np5, and noble gases will have electronic configuration as ns2 np6. Right, so that N can be a period number for a particular element. Say if it is argon, what is N? Argon comes in which period? You check it, 3, right? So argon's outermost electronic configuration is 3s2 3p6. So this way you have an importance for group number and period number. So group number actually tells you how many electrons can be present in the last shell. Okay, and all elements in a group will have similar outermost electronic configuration, so they behave in a similar way, they react in a similar way. Whereas period number will tell you which is the last shell present in a particular element. Okay, say for example tin is there. If I ask you which is the last shell, where is the electron present in a tin, I mean which is the last shell, then you will definitely check its period number. So tin comes in which period? Tin comes in fifth period. So the last shell that you find in tin is fifth shell. Okay, so your outermost electrons are there in fifth shell. And how many outermost electrons can be present in tin? You check it here. It is coming in 14th group. So its outermost electronic configuration is 5s2 5p2. Okay, so that's how you will come to know how many outermost electrons are there. Okay, so knowing about outermost electron is very important because they are the one which participate in chemical reaction. This losing and gaining business, sharing of electrons business do occur with outermost electrons itself. Okay, so this is all about, it's a basic idea that one must have about the modern periodic table. And now this modern periodic table is classified in different ways. They are classified into blocks based on electronic configuration. You have a classification based on their chemical properties. You have a classification, right? So now let us understand the classification of this periodic table. Okay, see students, so this is the first type of classification that we are learning. You know, based on the electronic configuration, the entire periodic table is classified into 4 blocks. They are classified into 4 blocks. The first one is S block, second one P block, okay, third one D block, and fourth one F block. So based on electronic configuration, this entire periodic table can be studied in 4 blocks: S block, P block, D block and F block. Then let's understand which are the groups that come under S block, which groups will come under P block, D block and F block. And you know what? The group number 1 and 2, okay, say with orange color chalk I am separating them. Okay, so group number 1 and 2, these elements are called as S block elements. So this is S block. So why do we call them as S block elements? It is because the outermost electron is present in S orbital. Okay, you check the outermost electronic configuration. See, outermost electronic configuration is ns1, ns2. That means the last electron is present in s orbital. You know, all of them to some extent show similar characters. So they are called as S block elements. Okay, so which all the groups will come under S block? Group number 1 and group number 2. Okay, and now let me show you P block elements. See, group number 13. Group number 13, leave helium. Okay, group number 13 to group number 18 will come under P block. Okay, so with pink chalk, I have separated them. So why do we call them as P block? You see, where is the last electron present? In which orbital? It is present in P orbital. That's why they are called as P block elements. Okay, fine. So depending on the last electron's location, we have classified into 4 blocks. If last electron is there in S orbital, S block element. If last electron is there in P orbital, P block elements. If last electron is there in D orbital, if it is there in D orbital, then it is called as D block elements. Okay, from group number 3 to group number 12, you will observe the last electron being present in D orbital. Okay, so that's why they are D block elements. And now you see here the 14 elements which were missing in this position and the 14 elements which were missing in the 7th period were separately placed at the bottom, right? And in these elements, let me show these guys with green chalk. Okay, so in these elements, the last electron is present in F orbital. That is the reason both the rows, we call them as F block elements. Okay, so actually we study about these elements in blockwise. You know, in the next chapters you will study about all the chemical aspects of S block elements, and you will also study 2 groups of P block elements. And about D block elements, F block elements, you will study in 12th standard. Okay, so we study the periodic table, we study the properties of elements block wise, sometimes in the group wise. Okay, say we don't study each and every element individually. It's not possible. So periodic table made our study of chemistry more convenient and comfortable. Say if we study them as a block wise, it's enough. It is understood that we know everything about each and every element. Okay, it's because that last electron, the chemical properties varies, right? So depending on which orbital the last electron is present, it is classified into 4 blocks, right? So now let us understand general properties of these S block, P block, D block and F block elements. Generally, we are not discussing in a detailed way now, because you have separate chapters only as S block elements, P block elements. There we will discuss in a detailed way. Now let us understand general electronic configuration and very general properties, what they can show every block elements. Okay, so let's understand general properties of S block, P block, D block and F block. Let's understand the points here. Coming to characters of S block. Okay, so actually NS1 to 2 is the general electronic configuration. So S block elements has two groups, group number 1 and group number 2, right? Group number 1's general electronic configuration is NS1. Group number 2's general electronic configuration NS2. I have already shown it, right? Say in general, all together we can write general electronic configuration NS1 to 2. That means S orbital can have 1 electron or S orbital can have 2 electron. That is what the meaning here, okay? 1 to 2 in the sense. S orbital can either have 1 electron or 2 electron. Okay, and these guys are soft metals. They are actually very, very soft metals and they have low melting and boiling points. And these elements are highly reactive. This point is really very important. Since they have 1 electron, you know what? On losing that 1 electron, they get stability. That's why they eagerly wait for losing that 1 electron. That's the reason we say they are highly reactive. And later, they are good reducing agents. When do you call something as a reducing agent? When an element undergoes oxidation. Oxidation in the sense what? Loss of electron, right? So as I already told you, for example, sodium, okay, atomic number 11. It has electronic configuration 1s1, 2s2, 2p6, 3s1. Right? If it can lose this electron, it gets a stable electronic configuration, right? So that's the reason always sodium likes to lose an electron. Anything that is losing an electron, process is called oxidation. So the one which is undergoing oxidation is called as reducing agents. So they all always likes to lose the electron. That's why I can call all of them as the best reducing agents. And since they have single electrons, they act as good conductors of heat and electricity. So these are common characters, very basic characters I am dealing with in this chapter. But you have a separate chapter called S block elements. Their group wise characters you will try to understand. Okay, fine. And coming to P block elements. So this is very important, guys. As of now, remembering their general electronic configuration is very, very important. So what is the general electronic configuration of P block? It is NS2, NP1, 1 to 6. S orbital will be completely filled and P orbital will try to get filled from 1 to 6. Okay, so in 13th group elements you will have NP1. In 14th group elements you will have NP2, like that. Okay, it gets filled up to 6. And these compounds are covalent. So any compound with P block element is always covalent. Even they are reactive. Okay. And here 15th group elements are called with some special element name. 15th group elements. Okay. For example, your nitrogen, phosphorus, arsenic. Okay. So these elements are called with the name nictogens. They are called with the name nictogens. This is important. So, nicto, the word nicto means suffocating. Okay. So, when you inhale the vapors of these elements, you get irritation in the respiratory tract. Okay. You feel a kind of suffocation, irritation. So, that is why they are called with the name nictogens. P silent there. Right. And similarly, 16th group elements. 16th group elements, can you name them? Oxygen, sulfur, selenium, tellurium, etc. These elements are called with the name chalcogens. Okay, why we call them as chalcogens is because they have ore forming ability. Okay, ore forming ability. That means we know what do you mean by the word ore, right? Metals are always present in combined form, right? For example, sodium. In our nature, sodium exists in the form of NaCl or sodium oxide. If you take aluminium, aluminium exists in the form of Al2O3, bauxite. If you want pure aluminium, you have to extract aluminium from this particular compound. Iron exists in the form of Fe2O3. Zinc exists in the form of ZnS. right? You see oxygen, sulfur, right? So they have ore forming ability. They can combine with metal and exist naturally in our nature as ores and minerals. Okay, so that's why these elements are called as chalcogens, right? And coming to 17th group elements. So 17th group elements are called halogens. So this word you may be familiar with, right? Halogens. Why do we call them as halogens? It's because they have salt forming ability. They are salt formers. Na on combining with Cl. So which elements come under 17th group? Fluorine, chlorine, bromine, etc. Okay, say NaCl, we call it as a salt. KCl, salt. NaI, salt. Okay, so whenever an element combines with halogens, that compound comes under a category called salt. So they have salt forming ability, so they are called with the name halogens. Okay, and coming to 18th group elements, we call them as noble gases or inert gases. Helium, neon, argon, all of them. So why do we call like that? It's because they do not react with any element. Why they do not react? They are happy with whatever electrons they have. They have completely filled shells. I mean, NS2, NP6 is their electronic configuration. Okay, so 8 electrons are there in the outermost shell. They are very much happy. They don't want to lose electron. They don't want to gain electron. So they do not react with any elements. So they are called with the name noble gases or inert gases. Okay, so these are some special names: pnictogens, chalcogens, halogens. You need to know their meaning, right? So that is all about P block elements. And coming to D block elements, they will have an electronic configuration N-1, D1 to 10, Ns1 to 10. Okay, so for example, if I have to write outermost electronic configuration of copper, it is actually 3D10 4S1, right? You see here, what is N? N means principal quantum number. So 4 is N. What is 3 now? N minus 1. 3 is what? How do you get 3? N minus 1. That is 4 minus 1, 3 you will get. That's why N minus 1. If this is N, if this is the last shell, then where do electrons go? Electrons goes to third shell D orbital. Okay, so that's why this is the general electronic configuration. And these elements are paramagnetic. What do you mean by paramagnetic? Getting attracted to magnet. Okay, so if you keep near a magnet, they get attracted towards magnet. So this is the basic meaning of paramagnetic nature. And they have variable oxidation state. Variable oxidation state in the sense, you know what? Here in the S block, the first group elements can lose only one electron. They can't lose 2 electrons, 3 electrons. They can only lose 1 electron. Whereas our D block elements, depending on a situation, they can either lose 1 electron or 2 electron or 4 electron, up to 7 or 8 electrons they can lose during chemical reaction. So that's why we say they are having variable oxidation states. Okay, and next is they can act as a catalyst. So what do you mean by a catalyst? Anything that can speed up the reaction, chemical reaction, is called catalyst. Okay, and they are used to make alloys. You all know what do you mean by alloy, mixing of metals, right? So these elements are best suited for making alloys. Okay, and coming to F block elements, so nothing much to discuss about F block element as of now. Just try to know about the general outermost electronic configuration of F block. Okay, so it is N-2, F1 to 14. F orbital gets filled from 1 to 14. N-1, D orbital gets filled from 0 to 1. And Ns, outermost shell, is completely filled. I mean, outermost shells, S orbital, would be completely filled. Okay, so anyway, about their general electronic configuration and whatever it is, you will learn in a detailed way in the individual chapters. Okay, so just this is the basic characters of those elements, right? And now we will learn about one more simple classification based on their nature and properties. See students, this is other type of classification. See, based on electronic configuration, we had SPDF, and based on the chemical properties and the nature or characteristics of elements, we can classify periodic table elements of periodic table into broadly metals, metalloids, and non-metals. Okay, right? So this is based on their nature. So what do you mean by metals? We all know the characters of metals, non-metals, and metalloids, right? So metals are good conductors of heat and electricity. They will have single electrons in the last shells. Metals can able to give their electrons during chemical reactions. All of them we must have studied in our previous classes, right? Say more details about these metals you will come to know in the later chapters, but this is how generally the elements are classified based on nature and properties of elements. Okay, so now which groups can come under metals? Group number 1, group number 2, as well as group number 13 also to some extent can come under metals. Okay, so mainly we talk about group 1 and group 2. Okay, and where are these groups placed in the periodic table? They are placed in the left side of periodic table, right? So this is left side and this is right side. So whichever groups that come on left side, that is group 1 and group 2, they will have characters of metals. And coming to non-metals. So non-metals group almost from 13 to 18 groups can come under non-metals. It's a 13th group, the aluminium, all of them have little of metallic characters, but generally I'm talking about the p block elements usually can come under non-metals, right? And I can also say the right side of periodic table. Okay, right side of periodic table elements can be called as non-metals. And coming to the metals, we all know when something has both characters of metals and non-metals, we can call them as metalloids. So usually group 3 to group 12 can come under this metalloid category, right? Fine. And this is one way of classifying elements. And we can also have certain different names whose meanings are very, very important to understand. We have something called representative elements. Representative elements. So usually what are representative elements? Group number 1, group number 2, 13th group, 14th group, 15th group, 16th and 17th group. Okay, so I can say S and P block except 18th group element are called as representative elements, and these representative elements can be more reactive. So they are generally reactive elements in our nature, right? So these group elements collectively, since they are more reactive, we call them with a common term representative elements. And next there is another term called transition elements. So what do you mean by transition elements? So usually D block elements are called transition elements. Sorry, D block, that is group number 3 to group number 12, they are called transition elements. Whereas one more term is there, inner transition elements. Inner transition elements. Say F block elements. F block elements are specially called with the term inner transition elements, right? So this is all about the classification of elements in a periodic table, right? So we understood everything about the modern periodic table and the different names and the different terms, right? And in my next class, I will come up with a super trick to identify the location of element. So about the location of element, questions can be asked in the competitive examinations like JEE, NEET, CET, whatnot. Okay, so I will tell you easily how to find group number and period number of an element in a periodic table. Not only that, we will try to learn IUPAC nomenclature for the elements above atomic number 100. Okay, so if an element has an atomic number 110, how to name it? We have certain rules to follow according to IUPAC. So all of them we will learn in my next video. Till then, take care and revise the concept. Do subscribe our channel to learn the concepts in the easiest way. Meet you all in the next class. Thank you.